Hello everyone. So after a long time, I'm back with another session in refrigeration and air conditioning. So we have stopped with the properties of refrigerants, types of refrigerants and their designation. And from now onwards, we are going into in-depth analysis of refrigeration components as well as air conditioning systems. So to start with, we will have the discussion on the four important components of the refrigeration system, namely compressors, condensers, expansion devices, and evaporators. So in this session, we will be discussing about refrigeration compressors. So these are the major functions of a compressor. So you know that in a vapor combustion refrigeration system, the name itself signifies that vapor compression refrigeration system. The refrigeration vapor coming out of the evaporator. So in the evaporator, what is happening? So in the evaporator, the refrigerant, liquid refrigerant is getting evaporated or changes its phase from liquid to vapor by absorbing thermal energy or heat from the space to be cooled. So that vapor refrigerant needs to be pumped or increased in pressure and temperature to reject the heat in the condenser. Okay. So in order to maintain two different pressures, the component used is the compressor as well as expansion valve. Expansion valve reduces the pressure, the compressor increases the pressure. So the first and most important function of the compressor is pumps the refrigerant vapor. That means the vapor refrigerant is getting pressurized to a very high pressure and temperature. Now let us see the various functions in an animation. You can see here this is a compressor. Okay, the inlet and outlet. The inlet, this line is from the evaporator and this line goes to the condenser. Fine. So usually the refrigerant is known as the heart of the system. Without refrigerant, I mean the compressor. The compressor is known as the heart of the refrigeration system because it is the device through which the external work is given to the refrigeration system. Only through the external work, heat will be transferred from low temperature reservoir to high temperature reservoir. So the first function, it pumps the refrigerant, similar to our heart. Heart is pumping the blood to different parts of the body, right? Similarly, the compressor pumps the refrigerant from the evaporator to the condenser. Okay, so the blue line represents the line from evaporator at low pressure. This is a high pressure region. The pressure is increased, for example, from 69 psi gauge to 278 psi gauge. So that much pressure difference you may experience in a compressor. Temperature also gets increased. For example, say 60 degrees Celsius to 125 degrees Celsius. Now the condensation happens in the, it can be of liquid cooling or air cooling type of condenser depending on the application. So the condenser types and the functions of the condenser we will discuss in a separate lecture later. Okay. Now coming to the classification of the compressors. Basically, the compressors are classified into two: positive displacement compressor and non-positive displacement compressors. So under positive displacement compressors, you can have either rotary type compressors or reciprocating type compressors. So positive displacement means there will be certain chambers which contains volume of the working fluid which decrease in volume during compression. So during compression, the volume of that chamber gets decreased. Coming to the non-positive displacement compressors, they have fixed volume chambers similar to the centrifugal pump. You have studied centrifugal pumps, right? So centrifugal compressors, they have fixed volume. The volume does not change. A certain volume is getting compressed continuously. Now, other type of classification is like this open type, where the prime mover, motor as well as the compressor are placed separately. There will be separate housing for these two. Hermetic type, both are mounted on the same housing. Both the motor and the compressor are mounted on the same housing, sealed together. Semi-hermetic type, but it will be motor as well as compressor will be in the same housing but with separated bolted covers. So this is a common example. You can see this photograph of open type compressors. So this is a compressor and this is a motor. There are separate mountings for compressor as well as motor and separate cooling mechanism fans you can see here. Fine. And the converted mechanical energy from the motor, electric motor, will be transferred to the compressor via suitable drive mechanism. Here it is a belt drive. Okay. Through belt drive mechanism, the converted mechanical energy is given to the compressor. Semi-hermetic sealed compressors you can see here, semi-hermetically sealed. Still, both the components are there, motor as well as compressors are there, but still they are on the same mounting. You can see here the same foundation bolt, the same mounting, but separately covered. So this is a motor and this is a compressor here. Hermetically sealed, you may not be able to distinguish between where the compressor is located and where the motor is located. This is the most commonly used type of compressors in our refrigeration systems. You might have seen in your household refrigerators, rear bottom side, you might have seen like this, a black object like this. So this is a hermetically sealed compressor. Both the compressor and motor are mounted in the same housing. You can't see them separately from outside. Once you open the cover up, then only you will be able to see the compressor and motor. Both are mounted on the same shaft. Okay, so there is no separate um, power transmission mechanism required. Directly, power will be transmitted. The commonly used compressor types in heating, ventilation and air conditioning HVAC are going to be discussed here. Reciprocating, positive displacement compressor, scroll compressor, screw compressor, rotary compressor and centrifugal compressor. So the first four, reciprocating, scroll, screw and rotary, are positive displacement compressors, and centrifugal is of dynamic compressors, non-positive displacement compressor. You can see here a reciprocating compressor, you know that there will be a piston cylinder arrangement. Scroll compressor, it is just like an archimedean screw type. I will show you the detailed schematic diagram. Then screw compressor, there will be two engaged meshed screws. A rotary compressor could be of vane type, moving or fixed vane type. Centrifugal compressor, the working principle is same as that of a centrifugal pump. Now coming to the first one, positive displacement compressor, reciprocating or piston type compressors. You can see here there is a piston connected to the connecting rod and a shaft. The piston is placed inside the cylinder with appropriate piston rings. There will be an inlet valve as well as outlet valve which will be operated depending on the pressure difference on either sides of the piston. There will be lubricating oil to maintain proper lubrication between the moving parts. So this is very simple in design and it's common, very common, right? So valve position is controlled by the pressure difference. You can operate in large power output range. The initial cost is very less. The vibrational issues obviously are there if it is not, especially not mounted properly, and maintenance. So if at all this oil level is quite low, what will happen? There will be friction, heat generation. It will burn the piston rings, even gaskets, or the internal surfaces of the cylinder may get damaged. So maintenance point of view, it is not good. Scroll compressors, you can see there are two identically machined scrolls. One scroll is stationary, the other one is rotating orbits. Okay, so the outlet will be from the center, the inlet will be from the periphery. So they are very quiet, smooth operating units with few moving parts, because only one of the scrolls is moving, the other one is stationary. So you can see here the compression chamber, this pink one is the compression chamber. It is getting reduced, the chamber volume is reduced, as a result the compression happens. So it is having the highest efficiency ratio among all the compressor types. This is a 3D model view of the scroll type compressors. You can see here this suction happens through here, okay, and the discharge after getting compressed, the scroll will be arranged here, and here will be the discharge. Now coming to the screw compressors, a pair of helical screws or rotors which are meshing together as shown here. So they compress the refrigerant between them. So the refrigerant will be admitted, and when the screws are rotating in the opposite directions, it will get compressed and will be discharged. Same thing, the chamber volume gets reduced, as a result of that pressure will be increased. Now coming to the rotary compressors, there could be moving vane compressor and stationary vane compressor. So in this case, the second one, the vane is stationary, but here you can see in this animation the vane is moving in and out in this slot. The vanes are moving in and out of in their slots when the rotor is rotating. As a result, the compression happens and it is discharged. This is the inlet and this is the outlet. But here there is an eccentric rotor, okay, or roller. Eccentric rotor or roller is moving inside the main cylinder block. Okay, so there is a fixed vane. That fixed vane controls the chamber volume. So it is coming in and it is getting discharged. So this is a 3D model of the vane type compressor. So these rotary type compressors are having low rotational speeds, low initial as well as maintenance cost, but the disadvantage is the outlet pressure will be quite less when compared to the reciprocating type compressor. Now coming to the dynamic type of compressor, non-positive displacement compressor, the obvious example is centrifugal compressor. It uses an impeller. Instead of a rotor, it uses an impeller. Okay, so there are no pistons, valves or cylinders. So it is well suited to compress large volumes of refrigerant to relatively low pressures. So you can recollect the working of a centrifugal pump which you have studied in hydraulic machinery. So the same principle, the inlet will be at the central axial inlet and radial outlet. Sorry, not radial, tangential outlet. Axial inlet and tangential outlet. So that's all about the compressor types, and this is the way by which compressors are designated or specified, the capacity of the compressor, what is the power input power requirement to get the compressed output, then the temperature at which it is delivered, the inlet temperature, that is the evaporating temperature, then the flow rate of the refrigerant through the compressor in kilogram per hour, and the power consumption, how much power the compressor consumes, the compressor motor, how much power it is consuming. So all these are the various ways by which the compressors are specified. So thank you for watching. If you have any doubts, please use the comment section below. We will continue with the other component condenser in the next session. Thank you for watching.